If y varies directly as x and y equals 10 when x equals 2.5, find y when x is 15. For this problem, both variables x and y are in abstract form. In short, there are no real-life representations for them. But we already given that this is actually under a specific type of variation we also call direct variation. Why? Look at the statement. If y varies directly as x, we are sure of that. And since, again, there are no real-life representations for the variables, we can still say that y, or variable y, is your dependent variable, and that would be x as our independent variable. To do this, we just simply need to substitute whatever given values we have on the correct mathematical equation for direct variation. And if I may, the formula is y equals kx, where k is a constant of variation or the constant of proportionality. Later, we are going to solve for k, and that k will be true for all the rest of the situations under this specific problem. But of course, we could write it here, a pair of x and y variables that we could use it later here. As we know, x is still the independent variable and y is your dependent variable. The first pair of values is where y equals 10 when x is 2.5. This is the first pair of values in a given situation, and we will be using that to solve for a specific value of k, to which we're also going to use later. Later, I mean we are going to use that when we look at the relationship of what is the variable we're going to solve for. Here, we are tasked to solve for y when x is 15, so we are sure that x should be 15, and y is what we don't know. So let's just plug in the first pair of values here to solve for k, and that would mean 10 is equal to k times 2.5. 2.5, or also known as 5/2. Let's apply the properties of equality here, specifically division property. Let's divide it by 2.5. Here as well, we divide this by 2.5. Next is to cancel this out, and by symmetric property, we'll get k is equal to 10 over 2.5, or could also be written as, if we're going to assume that 2.5 is a fraction, that's 10 over 5/2. Using the concept of fractions, you can use the reciprocal of that. You will get a result of 20 over 5, which will ultimately give us a result of k, which is equal to 4. So this is the constant of variation for this specific problem, and that is the same value of k we'll be using in solving for what is unknown. We are solving for y. Still, the formula is y is equal to kx, and k is now sure to be 4 times your x is 15. So we use the same value of k, and with that we could get a result of y, which is equal to 60. So this is the value of y when x is 15. Or we could write it here, the value of y is 60 when x is equal to 15. This now ends the process in solving the unknown for this given example. The more you practice, the better the chance to understand math. This is a direct variation statement for math success. Let this k, the constant of variation, be this channel. In other words, the more you practice with your subscription, the better the chance to understand math. Subscribe now.